Let me wait for a few more seconds. If you're able to hear me, just say a quick yes in the chat window. No, it's on. The chat is on. I think people can respond. Okay, quick check again. If you're able to, now the chat is on. If you're able to hear me clearly, just say a quick yes. Okay, I get that. Thank you. Thank you for doing that. And apologies for the initial inconvenience. I'm still going to wait for a few seconds. I see around 150 people who have joined the session already. I'm sorry to keep you waiting for that for a moment. But those of you who can hear me and who have joined the session right now, let us know which city you are dialing it from. So in the chat window, quickly let us know the city you are dialing it from. Okay, I see a lot of people from Mumbai, Kolkata, Pune. Okay, I see Uttar Pradesh, Ghaziabad, Hyderabad, Chennai, Bhopal. Okay, I saw someone from Islamabad. So great, welcome. Thank you for joining this session. I see 𝐀𝐻𝐿, Coimbatore. Okay, quite a few Mumbaiites. That's great to see. Mysore, 𝐒𝐻𝐿. Is that your Mallikarjun? Are you from NIT 𝐒𝐻𝐿? Possibly yes over there. But great. So I see audience from all over the country, and it's great to be hosting such a diverse audience. We have a very interesting session happening today. We are going to talk about how artificial intelligence is revolutionizing investigations in human trafficking and other such cases. We have an expert speaker on the panel. I'm going to kickstart this session very, very soon. I'm going to invite Dr. Robert Pless to talk to us in a moment, very shortly. But before we do that, let me run the first poll for the evening. It's going to be on your screens right now. This is around the likelihood of you pursuing a STEM master's in the US. So if you can see the poll question on your screen right now, please do respond. Let us know how likely or how interested are you to pursue a STEM master's in the US. Okay, I see the responses coming in. We're already close to 75 responses. So great, please keep those coming. There are 200 people in the audience right now. It would be great to see 100 plus responses. Okay, we're already 100 plus. So it would be great to see 150 plus responses over here. Shows us how engaged you are in this session. So please let us know how interested or how likely are you to pursue a STEM master's in the US. Okay, I'm going to keep this poll open for another 5 to 10 seconds. So if you haven't responded, please do. The poll is around how likely are you to pursue a STEM master's in the US. Great. So I have around 120 responses. I'm going to end the poll now and show the results quickly on the screen. So around 31% of the audience are very likely, they're very keen to pursue STEM masters in the US. 32% are somewhat likely to pursue STEM masters. 28% are unsure, and 10% are very unlikely. All right, so great. Those of you who are very likely or very interested in pursuing a STEM masters in the US, George Washington School of Engineering is giving an application fee waiver to the attendees of this session. So please, stay tuned with us, stay back till the end. You'll get to know, you'll get the waiver code from Erin shortly. But now let's jump into the topic for today, and let me invite Dr. Robert Pless to interact with us. I'm going to do a brief introduction for him. Dr. Pless holds the Patrick and Donna Martin Chair with the Computer Science Department at GW School of Engineering. That's George Washington School of Engineering. His research focus is geometric and statistical approaches to computer vision with applications to robotics and environmental and social justice. He holds a bachelor's degree in computer science from Cornell University and a PhD from the University of Maryland. He was a faculty in the computer science department at Washington University in St. Louis for 17 years before joining the George Washington University School of Engineering and Applied Science. And with that, let me hand it over to Dr. Pless to talk to us about how his work and research in the area of artificial intelligence is revolutionizing investigations in human trafficking cases. Over to you, Dr. Pless.
Thank you very much, Sanjay. I appreciate the introduction, and I really appreciate the chance to get to talk to so many people that are interested in computer science as a potential career. So like Sanjay said, I have the great privilege of being able to spend my life doing research in computer science, and I focus that in trying to understand computer vision, which is ways to program computers to better understand images. And I've done that across many different projects. And today I'm going to talk about a project that has some difficult pieces to it, but trying to work to better understand how AI can help fight sex trafficking through better image search. And the story is going to wander through many different components, and some of those also have difficult topics. But I hope at the end, everybody here can understand a little bit about my approach and some of the state-of-the-art approaches to better understand ways to build tools that use the power of artificial intelligence to really affect important problems in the world. So the particular context we're talking about today is trying to help people investigate sex trafficking. And the context of that problem says that people that do human trafficking or sex trafficking often operate out of hotels, especially in the United States and Europe. And they advertise online with images taken inside of hotel rooms. And if we can identify the specific hotel room that was used in an image, that can help find sex trafficking victims, document crime locations, and understand the patterns of behaviors of criminal networks. So it has these sort of three different directions that it can go. And to be very concrete, there is an example of a particular kind of picture, and this is actually a picture that came in an investigation of sex trafficking from Europol, which is the European version of Interpol. It's an international police agency. And this is a picture that they found as they were trying to help track down two trafficking victims, and they found this on a advertising website. So they literally did not know where in the world this picture came from. And their tools for trying to help this didn't work. And so they actually posted this on their Twitter feed. And there was a fascinating Reddit thread over the course of one long weekend where something like 400 people contributed ideas. And then somebody eventually actually found it, sort of by doing the grunt work of saying, I think it might be in this country, and I'm just going to look at all the hotel pictures in this country. So our goal today was to try to automate that process and make that something that doesn't require hundreds of people and a lot of luck to do. And before I start all the way at trying to explain our approach to this problem, I think there's a very good story about how I got involved in this research. And that story goes through a different path, but also talks a little bit about the real world implications of trust and AI and people and thinking about complicated problem domains. So this is kind of a funny slide. I'm going to talk through it for a while. It has lots of pictures, but it's going to help me to tell a story. So I hired Abby 𝐀𝐿𝐿𝐿, who is this person at the top left corner. She became my PhD student, and she's now a professor at St. Louis University. But I hired her in 2013 to help work on a project where we were trying to identify outdoor scene locations. And she came and saw this picture, this news article in the St. Louis Post-Dispatch, which talked about an 8-year-old girl who was found murdered 30 years ago. And no family ever came forward, and the police never found a good lead in the case. And so after about 6 months, they buried the body in a cemetery. And then 30 years later, the state had extra money to try to explore cold cases, and they wanted to dig the body up and to use modern DNA testing to understand more about the situation. And so they went to the cemetery and they dug where they thought the grave was, and they found an adult body that wasn't the right body. And they dug in the next grave site and they found the wrong body. And a judge said, you have to stop digging until you know where the body is. And so she said to me, she brought this news article in, and she said, this body was found 1 block from where my father grew up. And we are working on this project to figure out where in the world things are. And can we figure out where this is and help answer this question? And so I said, sure. And I thought to myself, either we're going to find it in one day, or we're going to realize it's impossible in one day. And of course, that didn't happen. It turned out to be about 3 months of work. But we produced a report that said, we think the body is right here, plus or minus 3 feet in either direction. And we did that by just using old school geometry. We found pictures of these trees and their geographic coordinates. We went to the gravesite and we used GPS, very accurate GPS, to find the locations of some of the gravestones that are hard to see in this picture. And then we said, what is the zoom level of the camera and where could the camera be that is consistent with those pictures? And so we made a report. and we sent it to the medical examiner, and they gave permission to dig again. And so then we went that day, and they dug right where they told us to, and they dug down about 3 feet, and they found an adult body, which is the wrong one. And Abby said something that you can only say if you're 23 and have that youthful confidence, which is to say, we're really sure we're right. You should keep digging. I would have had 100 reasons why something had gone wrong, but she said, you should keep digging. And they dug even deeper. And when they got to be about 6 feet underground, they found the body. And they were able to exhume it and do modern DNA testing on it. And there's a couple things about this story that I like. And one is things always take longer than it seems. But the second is one of the reasons that Abby had the confidence to say you should keep digging is that she had read everything that anybody had written over the last 30 years about the cemetery. And one of the things she knew was that the cemetery had gone bankrupt 10 years before, in part because they were selling grave sites a second time. So the idea that there was somebody buried on top of an older grave site wasn't a surprise to her, because she had literally read every word ever written about this document, about this case. So we ended up finding the girl, and they did modern genetic testing. And unfortunately, I don't have a great end to that story. From that testing, they found that she had grown up near the Gulf Coast, like maybe close to Florida in the United States. But they weren't able to get a more specific identity beyond that. But we were able to find the body and help push that case forward. Because of this, Abby was invited to the FBI Citizens Academy, which is a place for everyday citizens to interact with the FBI in the United States. And through there, she met this very strange group of travel agents that helped people plan trips, and nuns that had been working together to try to build tools for hotels to understand and fight sex trafficking. And one of the travel agents was actually a consultant for the FBI because she was a savant at being able to recognize hotel rooms. So there are some people that are famously able to recognize anybody they've ever met. She was able to answer the FBI's question. When they would show her a picture of a hotel room, she could sometimes say, oh, that is the Hilton Hotel on the north end of Chicago, because she just remembered that, like that was her special talent. And she had this idea, maybe we can collect images in order to understand where these pictures are taken. But she wasn't a computer scientist, and her idea of collecting images was sort of making a Dropbox folder that everybody could add to. And so we started this project just by trying to make a better way to collect images to support this. And that's something that you could even contribute to. We made an app. It's on the iPhone and Android store. It's called Traffic Cam. And it's supposed to help make the data that we have to search for hotel rooms different or more than just the big organized data sets. Like if you go to Google Places or Expedia or TripAdvisor, they have professional camera images taken by maybe the hotel manager and perfect lighting of a very clean room. And that's one kind of images that's very useful because we have a lot of them. But our app lets you log in and say, this is the hotel I'm staying at right now. Here's the room number, and then upload pictures that you have. And we were super lucky that this app was featured on CNN and Fox News, and we've had more than 250,000 people download the app. And we have about 400,000 images that people like you have taken of. Now it's more than 65,000 hotels, and we get hundreds of new images every day. And those images are very important because the kinds of pictures that you take as a professional trying to advertise your hotel are, like I said, of these very clean rooms and good lighting. And the kinds of pictures that come up in sex trafficking investigations tend to be maybe lighting later at night, so it's not as pretty of lighting, the room is more messy, and it's different viewpoints. You're much closer to the bed or much closer to people or the walls instead of standing in the very corner of the room to try to make the room look bigger. And these investigative images tend to be very close to the images that we get from Traffic Cam for the same hotel. So we have an important contribution from volunteers on taking pictures that look very much like our query images in our data sets. And we can try to build tools to say, let's make sure we can match images like this that we get from our users to images like this that we get from every hotel in the world. And so that's the process that we built. And we try to be good citizens of the research community, in addition to good citizens of the in terms of helping law enforcement. And so we published this as a data set. We call hotels 50K. It's 50,000 hotels out of the 500,000 hotels in the world. And it's been part of a collection of Kaggle contests. And if you are a student and you're trying to understand what it means to work in data science, or what it means to work in machine learning, or have some practice on real world problems that you might be able to write about in essays, exploring this website, Kaggle.com. It's sort of a very well-known professional website that lets you compete in contests, and you don't have to win contests to have interesting things to say, but beyond the contest and the chance of winning, it's also a very nice site because Kaggle itself as a company works very hard to curate data sets to make sure that you get to work on the real problem and not the problem that is finding and organizing data, which is the boring part that's really important and not everybody does so well. So given this data set, we work to train neural networks to create image features so that images from the same hotel are more similar than images from different hotels. And so on the left side, the top two pictures are two images from the same hotel. And you can see yourself maybe that this is the same hotel. It has the same kind of carpet. It has the same kind of runner on the bed. It has the same color of pillow on the top. Like there's many things that look the same, but it's from different viewpoints and different lighting. And often these kinds of features are hard for automated image analysis systems to detect that they're the same. And so our approach is to use our many, many, many millions of images to make many examples of two images from the same hotel, and then one image from a different hotel, and then to try to train the network to give a fingerprint of that image or to embed that image into a high dimensional space where the images from the same hotel are close in that high dimensional space, so they have the same fingerprint, and the image from the other hotel is different. And in my research group, we've looked at a collection of ways of defining loss functions for this that work especially well in this kind of problem domain, where the images from the same hotel may be pretty similar, but from very different viewpoints. Or sometimes I may have two images and one is from the bedroom and one is from the bathroom of that hotel. And so those images may not have common features. And the existence of that in the data set broke most previous algorithms. And so we've been looking at what we call the easy positive and hard negative triplet loss. And we had an ECCV paper where we call hard negative examples are hard but useful. And that was sort of a cute title for an exploration of different formal loss functions to make this neural network optimization go well. Once we have that search, we create the fingerprint for the 9 million images that we have in our data set, which is about 8.5 million images from TripAdvisor and Expedia and 500,000 images from our users. And if we have a query image that comes up in an investigator, they can load it into a website. They can mask off pixels that show sensitive content. Maybe it's people, or maybe it's something that the investigators don't want to share for some other reason. We do this masking inside the web browser, so we, on our server, never see those pixels, so we're not able to see, that's to give confidence that we can handle sensitive data because we never see it. If the investigator knows that it's like in a particular region, like by a particular city, they can do that, or they can do this search at the scale of the entire world. And then we rank all the images in our data sets and try to say which ones are the most similar. And so here's a case that works really well because this hotel in Chicago has a very high headboard, an unusually high headboard, and then these characteristic bits of art. And you can see that all of the top solutions find those features of a high headboard and very characteristic art. And so this is an example of our search working very well. Our search doesn't work all the time. It's especially hard for this type of algorithm to work when there's so much of the center of the image blocked off. But also the people that use our search who are exclusively at the National Center for Missing and Exploited Children in the US, they really care about these cases, and they're willing to look through many, many possible pages of results to see if they can find a hit, because sometimes this is the first lead they get in a particular case. So that is sort of the end-to-end endpoint without going into too much technical detail about how we have built this machine learning-based image recognition search and trained it specifically on data from hotels, and even more specifically on data that tried to match the images that our volunteers or the world has contributed through their smartphone apps to the data that we can get from all the hotels through Expedia and TripAdvisor. And one of the things that we found from our 𝐀𝐿𝐴 collaborators is that sometimes there were unusual matches that they didn't understand. So for example, there might be a picture like this, and then one of the closest matches might be an image like this that just shows a big window. And the question is, why is the algorithm doing that? And the reason somebody might want to ask the question of why does the algorithm think these images are similar is because they want to understand if they trust that that algorithm is giving reasonable results. And so another line of research that I've done is to try to do explainability or interpretability or grounding in these image similarity networks. And so we want to answer the question, if my network gave these two images similar fingerprints, what is it about these images that led to that similarity assessment? And one of the ways we can do it is following previous work that if you've done this domain, it goes by the name GradCam or class activation mapping. That usually works for a single image to say, why do you think this image is classified as a dog? And you hope that it sort of highlights the dog features. When we're talking about this kind of metric learning or embedding network or fingerprint generation, the question we're trying to answer is, why does the network think these two images are similar? And this heat map shows in blue the regions across both images that were deemed to be important. And that somewhat makes sense. It sort of shows like the curtain is highlighted in both cases, but over here we see the headboard of the bed and the floor, and here we see more of maybe the bottom of the chair. And this isn't so clear about why this is. So this was a paper, it's all black down here. This is a paper we published in 2019, and more recently we've updated that to try to highlight the specific correspondences. And if you're in the data science game, I can tell you almost entirely the way we do that is by saying at each location of this image, there is a version of the fingerprint. And we run PCA on that version of the fingerprint at each location. And that PCA can help us make a color-coded map that says not only what is important, but what is the correspondence between these features. So over here, we see the red of the curtain matches the red of the curtain. We see the green of the chair and the floor matches the green of the chair and the floor. And we see the headboard and the nightlight matches a little bit the nightlight over here. And so that kind of visual interpretability gives us more confidence that this image similarity search is giving useful and relevant features. So based on this project at George Washington University over the last 2 years, we have built Trustworthy AI as a strategic initiative that multiple departments across our school are trying to work on. And the technical approach to that is to say, let's understand how you could try to build better trust in machine learning. And one of the ways is maybe the easiest way and the ones that computer scientists think the most often. Let's build better machine learning algorithms because they give the right answer more often. And that's sort of the easiest definition. Like if I just have the right answer more often, that has to engender more trust. And I would trust it more because I'm building it and I know that it is working better. But other things we could do are provide ways to detail what the model is and how it was trained, and understand how we can explain to the users of this what the model is and how it was trained and how that matters. And so, for example, in our sex trafficking investigation search, before we had the pictures that people took with their cell phones as they were traveling, our system didn't work that well. And the reason was, even though we had the same model, it was trained largely on these pictures from professional photographers and not on the kind of pictures that came up from investigative searches. So it worked sometimes, but not nearly as well as it does now. And understanding how the model is trained was important to figure that out. I just last slide talked a little bit about the visualization tools of, for a particular image, why does the model give this answer? And then there's other things about understanding error profiles. And so this is something that the machine learning community does not think about very often. Usually they say, I want the right answer. But maybe there's answers that are more wrong than others. So in our case, there might be a classical kind of hotel, like here's a query picture of a sex trafficking victim. And maybe we don't get the right hotel, but we know it's a Hilton hotel. And so even though we give the wrong Hilton hotel, maybe there's only 3 Hilton hotels in Chicago and the investigator knows, okay, it might be another Hilton and I should look at those 2. And so understanding not just the machine learning approach that there's a right answer and a wrong answer, but some answers might be more wrong than others, or some wrong answers might still be helpful. That is an important part to integrate into the machine learning algorithms to help build trust with users. And another thing is the third-party certification. So if I want to use a machine learning system and I'm not a machine learning engineer, who could I trust to tell me that the system is okay? In the United States, there's something called, I think, Underwriters Limited, and every time you buy a fan or an air conditioner or a TV, there's a sticker on the back that says the electronics of this were evaluated to understand if it's likely to start a fire. Right? And so I don't open up the back of my electronics to see if I think they're going to start a fire, because I sort of trust the certification process. We don't have any certification process like that at all for artificial intelligence right now. But I do think as those tools become more and more common, we're going to have to build those kinds of certification systems. And the last thing is keeping humans in the loop. So in our image search for hotel recognition, we kept humans in the loop because our image search wasn't that good. It was sort of like a Google search. You do a Google search and you expect to have to look through the first page of answers to see the right one. And that was our way of doing it. But I think there's value in keeping humans in the loop, even if the AI system could give a pretty good recommendation, especially if that recommendation has a big impact, like arresting somebody or approving them for travel or something like that. So one of the initiatives here at GW is really trying to build on this work. We have a big grant to support work on the design of trustworthy AI system that's led by me in the computer science department and 𝐿𝐸 who is chair of our systems engineering department. And there's some details about this. And one of the parts of this is a 4-course graduate certificate that you could add on to a master's degree here in computer science or systems engineering that tries to teach the very fundamentals of machine learning and artificial intelligence, but also decision-making under uncertainty and some of the systems engineering tools that explain how to make big, complicated systems that you're going to put into the real world. And what are the tools people use to try to understand how those will really behave in the real world that go beyond the computer science version of, I ran it on some test data. And so that 4-course certificate, I think, is a very important contribution that we are adding to the world. I don't think there's any other certificate that looks like that. And it's something that's available for master students here. I wanted to very briefly talk about some of the other initiatives and strengths at the GW Engineering School, and then I'll stop for questions. We are the #2 ranked research engineering school in the United States that has 83 or fewer faculty. If you haven't heard of us, that's because 83 is not such a big number. And I admit that 83 is chosen kind of carefully, but I really, really, really love being part of a very small engineering school, because my collaborators are not just computer scientists, but they're people that study fluid dynamics and study robotics and drones and study optical computing. And if you come here and do a degree with us, you can choose to just be in your classes for computer science, and that's fine. Or you're going to be in this building, in one enormous building that has all of these different departments. And some of the most special research things we have are Volker Sorber, who works on optical computing. That's the idea of making computer chips that don't use electrons and wires as the way they move signals around, but they use lights. And that has huge advantages in terms of the heat that the chip generates. Because it doesn't generate so much heat, it can be smaller and you can do some kinds of processing much faster. We have an amazing group on high performance and next generation cloud computing. Tim Wood in the computer science department consults with Amazon and Facebook and Google about the right way to structure their massive computing servers and the right way to organize programs to be able to use really big computers when those are available, or to be distributed across lots of small computers, or to be farmed out to the edge in cases where that fits the computational profile. My favorite collaborator is Megan Leftwich. She works in the mechanical engineering department in fluid dynamics. She tries to study things like how sea lions swim through the water so effectively. The sea lion flippers flip and they make the swirls, the vortices that are in the water as they move through. And she and I are doing things like putting glitter in the water, because if you want to understand how fast the water is spinning, then you can do something like say, if I put glitter in, if I measure how long the sparkle lasts, that tells me about the rotation. If the sparkle is on for a long time and then comes off, it must be rotating very slowly. We're the only people in the world trying to use glitter as a way to understand the structure of vortices and fluid flow. And we believe we can understand smaller scale structures than any other cheap, large scale method of doing that. We have a group doing real-time autonomous systems. They think about drones and what will air traffic control look like if we have 1 million drones flying overhead, and usable computer security. We have Adam Aviv. He's famous for back like 10 years ago when people didn't have passwords on Android phones, but the idea of a password was just a pattern on your phone. But if your finger is a little bit oily, then that when your finger moves across it, it leaves a little streak. And he showed that you could take a picture of the phone from far away, see that streak, and then almost entirely decode the password. And so he thinks about this place where there's an interaction between cryptography, security, and algorithms, the way computer scientists like to think about it, and the real world that is messy and you can actually see what people are doing, and maybe fingers have fingerprints. Like that interaction between the real world and the cryptography part is a true strength of GW right now. So I work very hard to make sure that I leave extra time for questions, because I really love questions. And so I will pause here and open up the floor and ask, I guess, Sanjay to coordinate that.
Awesome. Thank you, Dr. Pless. This was extremely insightful and extremely relevant, really at the cutting edge of technology. We do have a number of questions that have come in. I'm going to take the most upvoted questions. So to the audience, what you can do is you can go through the questions list as well and like the questions that you find most relevant. This way we know which are the most important ones, and we can take up those 2-3 questions for Dr. Pless right away. I'm going to start with the first question. This has been asked by Kaustav. He's asking about if you can explain how AI actually performs when an attacker sends minted data to the AI. I'm not sure if I understand this question completely, but there are 12 votes for this. And if you can take up this question, that would be great.
Sure. So I'm not actually sure if I know what minted data is. I think there's a couple questions that are in this domain. So I think there is a problem in any kind of open data sets of the truth of the data. And so we tried to handle that in our case by making sure the app, when you upload a picture of a hotel, you're required to share your location. You're required to allow the phone to share the location. And some people don't want to do that, which we understand, but then we're not going to use that data, because otherwise it is the case that a little bit of data with bad labels can really mess up the machine learning algorithms. And so I think, a very small number of bad labels, maybe everything else works fine, but it's becoming more and more obvious that an educated attacker can use a few badly labeled data things or changes of the data to make real problems. And so we try to deal with that by scraping data from sites like Expedia that already do a lot of data checking. and then enforcing that the app users share their location to validate where they are.
Sorry. Kaustubh, I hope this answers your question. In case it doesn't, what you can do is you can post on a follow-on question and you can clarify your question a little more and we can take it up then. Coming to the next question, Dr. Pless, I think there are a lot in the audience who haven't had much exposure to AI before. And the request is if you can recommend certain books that they can refer, and books especially for beginners that they can refer to enhance their understanding of the domain.
Yeah, so I think different people have different approaches to this. And my argument would be, I don't want to recommend a book, but instead I'll recommend a set of tools, because I think this is the kind of domain where you can get involved in machine learning research at many different levels, sort of from a programmer with no mathematical background all the way to being a PhD in mathematics and trying to really push the algorithms. And the books really go across that whole domain. But one of the special things about machine learning is that it really affects real world problems. So my recommendation for anybody trying to get started would be to go to 𝐀𝐤𝐞𝐚, that website where we posted a problem domain, but it's 𝐀𝐤𝐞𝐚, it's �KAGGLE.com, and they run all these contests, and they have some sort of contests for beginners where people can get started, and there's a community of people that ask and answer questions on 𝐀𝐤𝐞𝐚. And then the way people kind of get started is to use, like, almost everybody uses Python. I personally like MATLAB better, but almost everybody uses Python. And Python and some of the libraries for Python, like scikit-learn, are really good ways to get started in this domain. And I think starting and actually looking at real data, even if it's a small toy problem, is a much better way to learn this than working through books.
So great. I think that's great advice to get hands-on practice by doing some live problems. I have posted the website link in the chat window. You can find it over there. That would be easier. What I'm going to do is I'm going to take up one last question for Dr. Pless right now. Then we are going to go to Erin and talk about the GW School of Engineering, hear more from her about the program, the various options of study over there. And then we'll come back to the Q&A. So you can stay in the room, stay with us. We'll take up more questions for Dr. Pless at the end as well. But my last question for now is around, this is a question asked by Rochita, who is asking, Google Lens would be able to identify the images and match them to some extent as well. What is the accuracy percentage for trace map? Okay, I don't know how to pronounce
my guess is that that last word is the traffic cam application. So for our system.
Okay. Yep.
Yeah, so there's the Google Lens, there's the Google reverse image search, where you can sort of put in an image and then Google tries to find similar images. When Google does that, I don't think they have as a goal to find images from the same hotel. Their goal is to find images that look the same, because that's sort of what the reverse image search is looking for. For our use case, I think I can give some accuracy percentage for our application, but there's a lot of context around that number. So when we look at our hotels 50K data set that we published, we have something like 10 to 20 images from each of 50,000 hotels. And when we put query images into that with our best models, we get something like 75% of the query images we get right within the first 5 answers. So our K = 5, K nearest neighbor matching is about 75%. But that's not really the application domain that we have. Like, the real world has images where so much of the middle of the image is usually blocked off because it's showing a person or other sensitive information. And so in that domain, we're down to something much more like 10 or 20% correct answers at the scale of 50,000. And so that's still really good, right? Chance would be 0.002, and we get 0.1 of the, like, our accuracy is like, out of 1 is like 0.1 instead of 0.0002. So it's way, way, way above chance, and it's useful, but it's not like 90% accuracy, like so many things. So I think that it's the real world applications that are super important. And one of the future research directions is to give the user or the investigator additional tools to say something like, I think this lamp in the image, in my query image, I think this lamp is the thing that's really going to help you the most. And then we can make things like our fingerprint features about that lamp instead of the whole room. And we're hoping that that gives some additional tools for the real world use case. But that's a really good question. Thank you.
Great. Thank you for that answer. We are going to continue this Q&A with Dr. Pless in a little while, but at this moment, let me invite Erin Vogt from the GW Engineering admission team to tell us a little more about the programs offered by GW and also how you can secure your application fee waiver in case you're applying to the master's program at GW later this year or early next year. So with that, over to you, Erin.
Thank you so much. I hope you can see my screen okay?
We can.
Great. Okay. All right. Well, thank you everyone for joining. It's great to have such a large and active audience with us today. So it's a little hard to follow Dr. Pless's a very interesting lecture, but I do want to just take a few minutes to share a little information about what it would be like if you decide you want to pursue graduate study in the US. What's it like to study at our university and what type of resources we offer our students. Let me tell you just briefly about GW. So well, we just celebrated a very important 200-year anniversary about a year ago. So we're a very well-established research university. I think one thing that's very interesting to our students who are interested in studying at the graduate level is that we actually have more graduate students than undergraduate students at GW. So that's opposite of many universities across the US, but it really speaks to the level of focus, the emphasis that we put on resources and opportunities for our graduate students. I'll also just mention that while we have 3 campuses in our region, the students that study in our on-campus engineering programs are all at our main campus in downtown Washington, D.C. And so you have access to that large city hub and the network of our region that provides so many opportunities to our students. Now, within our School of Engineering and Applied Science, we have 6 academic departments, 12 fields of study, 90+ faculty members. This number differs just slightly from what Dr. Pless was talking about earlier, because I think this includes a handful of our tenure track faculty members, and research spending. So as Dr. Pless had talked about, we're a very well-established research institution, and this spending number really speaks to many of the opportunities that trickle down through our graduate student population as well. I just saw some data yesterday that this number is actually up over 21 million in research spending annually for the current year. So we're very excited about that and the opportunities that brings. This is our science and engineering hall. So Dr. Pless's office, my team's office on the admissions team, much of the administration of the School of Engineering and Applied Science is going on in this building on a daily basis. And this is actually one of the largest teaching facilities in Washington, D.C. So we have a lot of advanced research labs, facilities, technical equipment throughout the building. And one thing that Dr. Pless had talked about earlier as well is the amount of interdisciplinary research that's going on in this building. So this was designed to really foster a very interdisciplinary approach to learning, to research, to development. We have offices within our science and engineering hall also for public health, for our medical school, other parts of the university. You can imagine, for example, the last couple of years during the COVID-19 pandemic, there's been a lot of collaborative research going on to kind of help find sources of information, to find solutions. So our building has been really a focal point of research across the university. If you want to check it out on our website, we would love to have you join our virtual tour. So this is an immersive virtual tour where you can actually sort of step in and walk through our building. So when we talk about it being collaborative and interactive, much of the inside of our building is glass. And so you can really walk through the building and see the research that's going on, see the work that students are doing, see where you yourself could study or research or be engaged as a student in our program. So we'd love to have you check that out. And then here's just a little more specific information about the graduate level programs that we offer. So if you are considering a program, these are our core areas of MS and PhD programs. A few of the programs are MS only, but of course, covered in the topical areas within the PhD programs as well. We do offer programs like our data analytics program is an interdisciplinary program between the computer science and engineering management and systems engineering department. So you'll find a lot of interdisciplinary work actually within the degree programs as well. Our master's programs are typically 1.5 to 2 years. And they are all thesis optional. So depending on what your long-term goals are for your academic goals and your professional goals, you have the flexibility to build the plan that will work best for you. And then our PhD programs typically take 4 to 6 years. It just sort of depends on your academic background and the research that you want to do as part of that program. Now, just to talk about the admissions requirements, I won't spend too much time on this, but please feel free to ask questions afterwards if there's any more information I can help provide. But essentially, a lot of people I know get a little bit daunted by the process of applying to a graduate program. It's really not so bad. We have an online application form. As Sanjay had mentioned, we're very happy to offer application fee waiver to anyone who joins our live sessions, such as this one. So you can see that up on the screen, SEED OCT for October 2022. That will waive your application fee if you do decide to apply anytime in the next year or two to one of our graduate programs. We do require English proficiency scores. We take TOEFL, IELTS, and Duolingo. We do not currently require GRE. You're welcome to submit it if you've taken it. You're welcome to submit that in support of your application, but it's not mandatory. We require 2 letters of recommendation from MS or 3 for PhD programs. A statement of purpose, a current resume, and then your transcripts. So if you're a student in India, for example, that includes your individual semester mark sheets, but basically just your academic records for anywhere you've attended so far. That's the application package. And my team works with thousands of students a year on completing this package and getting it through to our academic department. So we're happy to help answer any questions that you have. We're currently getting an influx of applications for our next available term. So that would be fall 2023, August 2023. And that application deadline is January 15th. So over the next couple months, as I mentioned, we'll be working with thousands of applicants who are interested in coming for the MS or PhD programs here, and we'll be happy to work with you on the same. Now, funding is something that we get a lot of questions about as well. So I'll mention briefly the funding structures that we have here at GW at the School of Engineering. And again, happy to take any questions. For MS students, we do consider all applicants for our merit-based scholarship opportunities, which typically range from 25 to 75% of our tuition cost. These are competitive. They're based on our overall applicant pool for the year. So we take a look at all the applications that came in after the deadline, and we start awarding these scholarships. You don't need to do any separate application process for this. This is something that we'll consider you for if you're eligible for any of our funding opportunities. Doctoral funding, faculty members in the department will consider all applicants for their available opportunities as well. You don't need to do a separate application process for funding. And typically, if you are awarded funding at the doctoral level, that would include a full tuition award as well as a living stipend for your time in the program. Again, so these opportunities are all very, very competitive and they're merit-based, but there is no separate application process. So you would follow all the same application procedures, the requirements, and the deadlines, the next big deadline being January 15th to be considered for any funding opportunities. And then I'm almost done here. I'll wrap it up quickly, but I just want to take a minute to talk about sort of career and professional outcomes. So we talk about getting into a program and what does a program look like? What is it structured like? How long does it take? But you know, we understand that the point of doing a program is to really build yourself professionally, to improve your profile and get some great career professional opportunities after you finish your graduate program. So we have a lot of advantages here in Washington, D.C. and within the School of Engineering engineering that we want students to understand. As Dr. Pless mentioned, we have very accessible department sizes. So we're, we're not a huge university where you get lost in the shuffle, but we have a lot of opportunities for individual engagement with faculty members, for participation in research, for joining events and organizations throughout the university. So we really encourage our students to get involved and to get to know everyone throughout the department and the school. We have a lot of connections with employers, with organizations that allow our students to get internships, to get research opportunities, positions after graduation. And so you'll find a lot of diversity of employers in our region. We have tech organizations like students working with Amazon and Facebook and Meta and things like that, as well as a lot of research institutions, a lot of government-funded research projects, independent organizations, international organizations like the World Bank, which is located right beside our university. So there's really such a diversity of opportunities depending on your interests and where you'd like to go with your degree program. We have a career services center, of course. This is actually within our School of Engineering, so it caters only to our engineering and computer science students. Many of our students are international, so our career services coaches are very well versed in working with you through the process of what work permissions you need to get employment opportunities, to get internships. We have the experts to work with you on that, so you don't need to worry if those opportunities would be available to you as an international student. They also try to organize a lot of engagement with alumni, local networking. They organize interview days with employers where they come to campus and interview our students directly. So there's a lot of work being done for you to ensure that you get the outcome that you want. And as I mentioned, they work regularly with a significant number of international students. So you'll find students who are on CPT or OPT. So these are the work permissions in the US that come after studying on a student visa, during or after studying on a student visa. And our team works very closely with students to get positions that fulfill these requirements with major organizations so that you can get the experience that you're looking for as part of your academic program. And then finally, I just want to mention our current graduate student ambassadors. So this is my last slide, and then I'll turn it back over for any questions that we can help address for you. I'm so glad for those of you that stuck around. I hope this has been really helpful for you. So these are just a handful of our current students. They are always available on our website, which is at the bottom of the screen, as our graduate ambassadors. So they are available to chat with you about any questions that you have. You might have questions about students that have come from your country or students that have joined the program that you're interested in, or what is it like to work with the faculty at GW? Any of those questions, our students are more than happy to chat about and kind of tell you their firsthand experience. So as much as faculty and staff like us can help answer your questions, we want to make sure that you have that connection directly with students in our programs as well to learn a little bit more about what it might be like for you. So we hope that is helpful for you. And finally, we're very happy to take whatever questions you have remaining at this point. Our website is up on the screen that has all the information that I talked about today about the types of programs that we offer, our graduate ambassadors, our funding, our application process. This email goes to myself and my team of a few people that are here to answer any questions that you have. We try to get back to everyone within a day or so. And please use the application fee waiver if you decide to apply to one of our programs. It also just reminds us that we talked to you here this morning, and we'll be very happy to see your application come through for our master's or PhD programs. So I'll turn it back over to Sanjay to navigate any questions that we have, but thank you all so much for sticking around.
Thanks, Erin, and thanks to Dr. Pless for sticking around as well. We do have a number of questions which had come in. I want to encourage the audience to ask more questions. We have another 10 minutes with us. We can probably take 4 or 5 more questions. So do ask questions. Please upvote the questions asked by others as well. This way we know the most relevant ones and we can answer those for you. Let me take the next most upvoted question. I think Dr. Pless, you already answered this, but I'm going to retake this one. This is a question from Manikanta Sampri, who is asking that most of the learning that happens in the ML and AI domain is unstructured. Any suggestions and inputs for beginners? So I know you mentioned the 𝐀𝐤𝐞𝐚 website, but besides that, any other resources that they can use to make their learning more structured and get more insight into the domain of machine learning and artificial intelligence?
Yeah, so that's a great question. And so I have this bias that says you should just dump in and do things, but I also understand that people really like to have something more structured. So I put in the chat suggestions of 3 books. The first one is sort of practical coding based that has exercises that you should actually do, and it's based on Python. And then 2 of the more mathematical books, An Introduction to Statistical Learning, should be accessible to anybody who has sort of a sciencey background. And then if you have done a lot of statistics already and you want to know the statistics that are most important for machine learning, the book called Elements of Statistical Learning is my favorite for that.
Awesome. So great. Those books are in the chat window, so do check them out. They can be extremely useful and relevant. Dr. Pless, the next question is around improving the accuracy. We understand that it's extremely challenging. This is a question which has come in from Abhishek. He's asking what can be done to improve the accuracy of machine learning programs further, especially programs that use image processing.
Yeah, so that's a great question. And there's a couple different directions that you could think about that question. So one is, what are better algorithms or better neural network architectures that you could use? And there's an enormous literature on that at conferences like NeurIPS and ICML and ICLR. I think if you care about a particular problem, a particular specific problem, like doing better hotel recognition, or you are a naturalist and you're trying to understand how to classify different kinds of butterflies, it's almost never worth it to work on the underlying structure of the neural network. If you care about a particular problem, it's all about the data. So getting as much data as you can from your problem domain. And then there are some tricks that people use a lot to try to take a medium amount of data and make it more data. And so those tricks go under the name data augmentation. And there are things like, if you have an image, maybe of a hotel room, and you flip the image left to right, so it's the other way around, that's probably also a good example of an image that you might have gotten. Like, it's not one of your images, it may not really exist in the real world, but you might get an image that looks like the same image flipped around. And so there's a little bit of art in building and training machine learning algorithms and understanding what the right data augmentation tools are. But I think that's the sort of first step, is get as much really good data as you can, and then understand what data augmentation makes sense in your problem domain.
All right, great. Thank you, Dr. Pless. I'm going to come back with some more questions. There have been some interesting questions that have come in. But Erin, I want to take one question for you now. The question is around how competitive it is to get through to GW engineering, right? I think this is, Society asked more about the chances for an ECE engineer getting into GW University, but if I have to make it more broader, how competitive it is and what can the attendees do to improve their chances of getting through?
Sure, great question. So I think there's a few different elements of this. So I think for master's applicants, one thing to keep in mind is that generally we look for applicants who have a base level knowledge in the field that you're applying to. So for example, if you're applying to the computer science program as an example, many of our students are coming with already a bachelor's in computer science or a related field. If not, if you're coming from some other sort of tangential field, you may have just some basic coursework completed in statistics and programming, something that gives you, the knowledge needed to succeed in these advanced level master's classes. So we are looking for that generally, and typically what we see is a 3.0 or better on a 4.0 scale for previous GPAs. So that's just to give you some idea. And I know that doesn't translate well to the Indian grading system, but you can use online calculators just to get an idea of what that would be for you in your grades from your bachelor's program. So once you meet the basic requirements, we're looking a little more closely at your background and, do you have any work or research experience? What do your recommenders say about your ability to succeed in graduate level coursework? So we're looking at those factors. And then finally, I would say in terms of increasing your chance of success in the application process, just really be specific about what you're looking for in a graduate program. So we genuinely want to understand, why do you want to come here to GW, to the School of Engineering, and how can we be a good fit for you? So your statement of purpose is a great place to talk a little more about your background and how you got to this point of wanting this master's or PhD program, but also what do you hope to get out of it? What do you hope to learn during your time with us? And what are your professional goals? Why do you think our program is a good fit for you? So you attended this session with Dr. Pless and you were really inspired by what he talked about. Be specific. You saw some of the research that Dr. Megan Lethbridge is doing, and you're very interested in that research, and you would love a chance to study in one of her courses or something like that, that tells us that you've really taken some time to look at our university and you think that we would be a great fit for you. That helps us be more confident that you're a great fit for our program too. And yeah, we would love to give you that shot if we can.
Awesome. So yeah, your sessions like these are great example or great opportunity for you to get a live understanding of how teaching takes place at GW, how the kind of faculty they have. So make the most of these, attend as many of these sessions and bring those into your application as well. I'm going to take possibly my second last question for the evening. And Dr. Pless, this is more around the emerging areas or emerging problem areas that can be solved through AI. So this is a question which has been asked by Mohammed Atif. I know it could be multiple things. There can be so many implications for AI across industries, across domain areas. But if you had to talk about the future, right, and if you had to look at the top 2-3 areas or problem areas that AI can be used to solve those problems, that would be great.
Yeah, so I've thought about this a lot, especially in my recent sort of work on our initiative of trustworthy AI. And I think one of the things we're finding is that we often don't trust AI very much, right? There's been billions and billions of dollars poured into self-driving cars, and there's a few, and they kind of, but it's like, for as much money has been put in, it's crazy that those cars aren't driving around. And I think if you look at the places where AI has been most successful, it's where the answer doesn't matter that much. And that doesn't mean it's not useful, but it's in problem domains where there is no possible way to do the question without AI. So something like a Google search is literally searching over 10 billion web pages to find something that relates to your query. And there's no alternative to some AI algorithm. And so somehow AI people have convinced us all it's our fault if we type in a Google search and don't get the right page. You're like, dang it, I need to come up with better search words. And so that's an example where like the AI is doing something really good because it's doing something we can't do. Like there's just no hope of us doing it. And therefore, whatever results it gives us is better than we could do before. And now in the last couple of years, we are starting to have AI push into places where mistakes matter so much more. So when AI starts driving your car and getting into car accidents, right, the mistakes matter a lot more. When AI starts evaluating visa applications, I don't actually know if we're doing that in this country, but if it did, right, that's a place where, like, I don't know if you think people are unbiased, but the AI algorithm like will also have biases, and is that the right approach, right? And do you trust it from from the side of somebody trying to get a visa to the US, or do you trust it from the side of somebody in the US that is trying to evaluate what reasons people are trying to come? And so as we get these systems that are really embedded in the real world in places where mistakes matter so much more, I think some of the issues I talked about on that slide about trustworthy AI, where it's not just accuracy, but it's what kinds of mistakes are you making? It's how can we actually certify that the system is doing something? How can we understand the risks and decide that they're acceptable? I think those are all increasingly important questions.
Great. Thank you, Dr. Pless. I'm going to take one last question, one additional question for you, and then I want to take one question for Erin as well. Dr. Pless, this question is from Samir. It's the top question on the screen right now. It's about, since Google is really good with its mapping database, do you think there can be synergies where the mapping database can be used for human trafficking cases, leveraging AI in between?
Yeah, so the Google Maps database, I think, is one of the engineering accomplishments, like the most amazing engineering accomplishments of the last like 15 years. The fact that like you can go to anywhere on Earth, and like that's amazing. And I know there's some tools and some groups that do really interesting work. So there's a group called Bellingcat. I'll put the link in the, and this is kind of a like the kind of group that maybe some people here get interested in. So they do open source investigations to try to help things. And they actually had, their group worked for 3 months a year ago on some sex trafficking investigation kinds of questions. And they often do things like use Google Maps and Google satellite views to pinpoint the location of pictures that come up on controversial news stories. Like, and so I think, like the question is very good because and it actually is already true. Like people are already as volunteers using things like Google Maps database to try to identify where pictures are for lots of different social justice reasons. In our research group, like as sort of a random researcher, you can't scrape Google's database. In fact, like they have teams that try to make sure they keep that intellectual property of all the data. But we have occasionally worked with research groups at Google to understand if there's ways that they can deploy some of our feature detectors. And in some sort of small cases, we've done that a little bit in order to use the real full Google database to try to do searches. And so that's kind of something that maybe to Erin's point, like one of the advantages of being affiliated with a really top university that has a research program, like we have some trust with working with Google and Amazon and the US government and so on to get access to some of the most amazing data sets that can have a big impact.
Great. Erin, so to the audience, my apologies. I know a lot of questions are still pending. Possibly we can't cover all of those in today's session, but I want to take up one important question, and this is for you, Erin. This is around people who are looking to apply to GW, right? How do they go ahead with selecting? Where can they get more information about the program? I know 15 January is the deadline. Is that the final deadline, or do you take rolling applications post that as well? And where can they go to get more information about the various programs and details?
Yeah, great question. Thank you. So January 15th is our primary annual deadline for fall admissions. So I do really encourage everyone to follow that deadline as much as possible. One important consideration is that really is a priority deadline for funding opportunities. So if you would like to have funding support as a PhD student, particularly as an MS applicant, we really do need to have your application in and all the materials in by that date so that we can consider you for the most available opportunities. For MS applicants, we will continue to review applications on a rolling basis for as long as possible. We're happy to do that for you, but as time goes on, of course, our funding would get more and more limited throughout the year. So in terms of where you can get more information, actually, let me see if I'm able to screen share with our website. Are you able to see our website here with some bottles and a video? Yeah, okay, perfect. So I just want to point out that this is our website that I had up on the screen before, graduate.cs.gwu.edu. This is where you can find all of our graduate programs. So if you navigate to master's programs, if you're interested in computer science, for example, you can click there. You can find more information about the focus of our programs. You can download a list of available courses, what the program requirements are. You can really get a sense of what it's like to study in that program and what the requirements would be. Also, some information about what we look for in the background of a candidate for the program. So please feel free to browse through the website, look through different programs, admissions, international admissions information here. You'll see information about our English policy. We try to put everything very clearly on the website so that you can work easily through the application process. Any students that are interested in applying, on every page of our website, there's this apply link in the upper right corner. You can click that button at any time to start the process. So I'll stop sharing there, but please feel free to use the website as a wealth of information. There's an opportunity on the website to make an appointment. These are individual appointments just with myself, 2 or 3 of my colleagues. Our job is to work with you and help you decide if this program is a good fit for you and help you through the application process. So we're always happy to jump on an individual meeting with you. If you'd like to talk further, you can find that link on our website as well.
Awesome, great. And Erin, GW is currently GRE optional, right?
We are GRE optional at least through the coming year. So at least through 2023, those are not required. If you have the scores and you'd like to submit them, we're happy to see them as part of your application process, but not required. So I know that's a relief for some students.
Great, that's great news. That's wonderful. And with that, we are over time. We are significantly over time on this session. I want to firstly thank our audience for being so patient. There are still around 150 people in the room. So thank you for being around. I hope you found this session useful. Thank you for joining in. And I also want to thank Dr. Pless and Erin for doing this session. Thank you for taking out the time and interacting with our audience. I found it extremely insightful, extremely enriching to know what's happening in the domain of AI. And I'm sure the audience have as well. This session is available on 𝐒𝐸H's YouTube channel. So in case some of you missed the session, didn't get the complete details, you can watch it over there. And you can reach out to the GW team or us with any questions or follow-on requests that you may have. So thank you again for doing this session. Have a great day, both of you.
Thank you so much, Sanjay.
Robert,
thank you so much.
But thank you. Bye. Have a great day.
Bye-bye. And thanks to all the people that came to listen. I appreciate it.